Next, question 2. Evaluate the definite integral from 0 to 1. So it's a definite integral because we have limits here. So that means once you integrate this, you're going to sub in the upper and lower limit, and then you're going to end up with just a number. So if I want to integrate 1 to 0 of the cube root of x squared dx, I want you to have the same instinct that you have when you want to differentiate something that looks like this. Well, I tell my students that anytime you have a surd or a x on the denominator, you want to change it back into an index form. So just as a recap, if you have a to the power of m on n, then this fractional power can also be written as a surd. So you have a square root of a, whatever is at the top goes on the inside, whatever is on the bottom goes on the outside. And have a really funny but also sad way of memorizing this. So, back in the, class system, very hierarchical system that we used to live in, whoever was on top sleeps on the inside, whoever's on the bottom sleeps on the outside. Yeah, so cruel, but you know what? It works with my students, so it might work with you guys too. All right, so now what we're going to do is I'm going to first rewrite it in index form. So whoever sleeps inside is on the top, on the outside goes on the bottom. And then now it is ready to be integrated. So careful because we're dealing with fractions. So what you're going to do is you're going to increase this power by 1. And before you touch your calculator, get used to adding fractions mentally. So if I just add 1 like this, you're going to be like, oh, I can't really add it because I don't have the same denominator. So instead, always add whatever's on the denominator over itself. And that immediately gives you 5 on 3. And now you can write divided by 5 on 3, but no teacher ever wants you to leave your answer as a fraction in a fraction. You see, he got this smaller fraction in this bigger fraction. So what I get my students to do is you kind of take the reciprocal of that thing you're dividing. So if normally you have a 5 at the top of the fraction, it's going to go on the bottom. And if normally you have a 3 on the bottom, it's going to go at the top. So it's like the reciprocal of the new power. Now, since this is a definite integral, meaning there's numbers here, I'm going to write this with square brackets, and then the limits go on the right-hand side. And this just means I'm going to sub this in. So now if we plug it in, we're going to get 3 times 1 to the power of 5 on 3 on 5 minus 3 times 0 to the power of 5 on 3 on 5. This goes to 0. Anything times 0 goes to 0. This whole thing becomes a 1. So then you're just left with 3 on 5. All right. Okay, question 3. Find the indefinite integral of this. So if you look at this integral, the first thing hopefully you should notice is that x is on the bottom. So using the negative index law, bring it back up. So just to recap, the negative index law says that if you have any base to the power of negative m, then you can actually rewrite this as 1 over a to the power of m. So if I were to rewrite this, we're going to get 5x to the power of negative 4 dx. So now if I want to integrate this, we're going to increase this power by 1. If I increase this by 1, be careful, it's becoming more positive. So it's going to become 5x to the power of negative 3. And then you divide it by that new power. Okay. And then just get the hang of bringing the negative that is only on the denominator, just bring it in front of the whole fraction. They mean the same thing. So just to recap, if I have 1 divided by negative 2, where the negative looks like it's only in front of the 2, that is the exact same thing as negative a half, where negative is in front of the whole fraction. Same thing, if I have negative 1 divided by 2, where the negative isn't only in front of the 1, it's the same thing as negative a half. So generally, just always try to leave it in the form where the negative is in front of the entire thing. And while I'm at it, I'm going to bring x back down to the denominator. So the general rule of thumb is leave your final result, your integrated result, in the same form as the original. So if you had an x to the 4, then you should have x to the 3 on the bottom.